So in the previous video, we discussed Avogadro's law. We discussed how volume and number of moles of gas are related. Specifically, they're directly proportional. Let's investigate this concept of moles and gases and volume a little more specifically if we are at STP. And STP is short for standard temperature and pressure. Specifically, those numbers, those values of STP are 1 atmosphere and 0 degrees Celsius, which is the same as 273 Kelvin. And this figure from your text, from MindTap, illustrates something interesting if you are at STP, a pressure of 1 atmosphere, 273 Kelvin, and you have 1 mole of gas. And it doesn't need to be just helium, it could be any gas. So if you have 1 mole of gas, regardless of its identity, and you are at STP, since you have 1 mole of gas, those gas molecules weigh different amounts, obviously, because they have different molar masses. But the number of molecules is still Avogadro's number. And what's interesting is that the volume of gas at STP is a constant. It is 22.4 liters. That is regardless of the identity of a gas. That can be very useful when doing gas law problems if you are at STP and you have 1 mole of gas. And we'll make use of that statement, of that fact, in problems on your Chapter 10 practice problem worksheet. And we'll do some in class or via Zoom as well. But I wanted to make that note to you before we move on with the other gas laws, because we have just talked about gases at volumes and different moles. If you are at STP, meaning 1 atmosphere and 273 Kelvin, and you have 1 mole of gas, regardless of the identity of that gas, your volume is automatically 22.4 liters. That can be a very handy conversion factor for you to use with particular gas law problems if you are at those conditions.